Hey y'all, we are Memphis Communiversity and we're back for another Calculus Done Wrong lesson where we wrong calculus before calculus wrongs us. Today we're going to continue our area and volume unit. Today we're going to do volume by cross section. So basically we're going to have these given regions and 3D coming out of the board will be a shape and we're going to find the volume of that resulting solid. But just like with our volume by revolution video, if you haven't seen that, it's a sort of a process that you have to know. We're never going to draw the 3D shape because I don't know how to draw. We're just going to apply the same process over and over again. And you'll see that this question isn't that bad because usually you don't have to do the integral that results from this process. All you have to do is set up the integral. And if you know how to do volume by revolutions, all of that inner radius and outer radius business with the washers, you'll see that this one will probably be easier, even if you can't picture exactly what the 3D solid you're actually going to try to find. So let's just talk about the process. Let's list out the steps and then let's go for examples. So again, this is volume by cross section. So volume by cross section. So what's easy about this one is that there's going to be two types. There's going to be ones that are perpendicular to the x-axis, and then there's some that are perpendicular to the y-axis. But that's a given, so just identify if it's perpendicular to the x-axis or the y-axis. Or y-axis. Again, it's just going to be stated, and that's the only option. X-axis or y-axis, keeping in mind that we prefer to be perpendicular to the x-axis, just like in our area and volume by revolution video or rotation video, because for y-axis, you have to change everything to y. So usually our function is going to be in terms of x, and we would have to change everything to y's, and we would have to remember to use y coordinates and not x coordinates. So that's that. The second thing is the given first is x-axis and y-axis, and the second given is going to be some shape. So what we're going to do is we're going to draw the shape. So we're going to draw the shape, whatever is given. The shapes that are usually on these are going to be squares, semicircles, isosceles right triangles, and also rectangles. So we're going to draw the shape that's given. Again, we don't get to choose it. It's a given shape. And the important thing is that the base of the shape, don't know how to spell the word shape, will either be top minus bottom or right minus left. If we're dealing with x-axis, we're going to do top minus bottom. If we're going to do y-axis, we're going to do right minus left. So the base of the shape is either going to be top minus bottom or right minus left, depending on step one. So right minus left. Then what we're going to do is we're going to find the area of the shape, and that's going to be a geometry formula. So 3 is going to be the area of the shape. And keep in mind that the area of the shape will be dependent on the base of the shape. So while we'll have different sides of the shape, obviously a square has 4 different sides, what we're going to consider as the most important side is the base of the shape, because the base of the shape will allow us to find the area of the shape. So the area of the shape is going to be dependent on the base. So it depends on base. So that's why we find the base of the shape first, the length of the base of the shape, either by top minus bottom or right minus left. So it depends on the base of the shape. Finally, all you do is you set up your integral. So the integral is going to be 2 different possibilities depending on if we're doing x's or y's. So the first possibility, so we have volume. It's going to be the integral of the area. We're just going to call it a of x. And if we, again, just like with revolution, volume by revolution or areas, what do you put on the integral? Well, if you're dealing with x's, you're going to put the x coordinates. So it's going to be a to b, where these are x coordinates. So what's the leftmost A of the region? What's the rightmost A of the region? And of course, if we are dealing with y's, then we're going to have volume be the integral of from c to d. So I'm just using different letters just to remind myself again, if I choose the y-axis, that's not actually a choice, that's a given. But if I'm dealing with the y-axis, everything is perpendicular to the y-axis. I do right minus left, and I have to change my numbers to y values. So it can be c to d. And then finally, you do the area in terms of y. And again, usually you don't have to do this integral. Usually you just set up this integral and that's the answer, or you type it in a calculator. So we're going to focus on setting up the integrals as opposed to finding the integrals. But again, this is the process. This process doesn't really make much sense right now, maybe because we haven't done examples, but try to write out these steps so that I can erase this board and then we can just apply this process to example questions. But first off, remember that there's going to be three main givens. You're going to have some sort of region. You're not going to have to choose the region, but the region will be given. Then it'll say that the cross sections that are coming out of the board, and I'll try to explain this in our first example, will either be perpendicular to the x-axis or the y-axis. So you just note that, and if it's the y-axis, you have to change everything to y's. Then it's going to have some given shape. It's either going to be a square, a rectangle. I don't know how to pronounce the word semicircle or semicircle, so I'm going to alternate between each one, but it's going to be either, it's going to be a semicircle or maybe an isosceles right triangle. So those are the four main shapes. What you do is you're going to draw that shape on the side of your work. The base of the shape will either be top minus bottom or right minus left. And why is the base of the shape important? Well, it'll allow you to find the area of the shape. And finally, to find the volume, you integrate the area of the shape, whether that be in terms of x's or y's. So let's do a question. So let's erase this. Hopefully you had a chance to write these steps down. Again, because it's a video, of course, you can rewind, the power of technology. But let's start off with this region. So I'm going to start off with this region. What it's going to be is going to be this function right here. This function is going to be y is equal to 2x squared. Then we're going to plug in, this region is going to be bounded by this line right here. So let's see, what is this line? Well, I'm going to have this value be, let's let it be 2. So then when we plug in 2, it looks like this is going to be 2 times 4. 4 times 2 is 8. So it looks like we want the line y is equal to 8 here. So again, this is going to be my region R. It's going to be bounded by, if you want to write it in sort of precisely, this region, it's bounded by these lines, bounded by the y-axis, the horizontal line y equals 8, and then the function y is equal to 2x squared. So that's the region. Again, it's a given. Then the other givens will be either a shape and whether it's perpendicular to the x-axis or the y-axis. So first off, as we deal with this region, my first one is going to be perpendicular to the x-axis. These are going to be my cross sections. And then we are dealing with squares. Again, everything that I've written on the board will be a given. And what we're going to do is we're going to find the volume of the resulting solid, where if we take this region, the base of the solid is this region, and then what's coming out of the board are going to be squares. So first off, I'm going to talk about this a little bit, but then I'm going to apply the method. Again, the actual resulting solid, you don't have to picture it perfectly, but what happens is, imagine that at every single one of these little lines that are perpendicular to the x-axis, you're going to have a square. So for example, the square is going to be around this long, because the base and the height are going to be the same. So hopefully you can imagine that as I pull out the square, I like to think of it almost as a bookshelf, where you take this line and you pull it out, and you're going to have a square that results, like the book that's pulled out. But hopefully you notice that as you get towards the left side, because the top minus bottom is so far apart, the squares are going to be bigger on this side, and then the squares are going to be smaller on this side. And because you have one for every single square, so for every single one of these lines, infinitely close, it actually ends up having a very nice round shape, because the squares are very, very next to each other. They're very, very close to each other. So again, that's going to be the region. It is very hard to picture the region. So that's why I don't like to draw the region itself. I feel like that's unnecessary. And anytime I do these questions, I can just focus on the 2D picture. But I did want to give you a sense of what's happening. You have this base of a base shape, and basically a solid is coming out of the board, where at every single one of these cross sections, perpendicular to the x-axis, you have a square. But again, if you don't want to think about the 3D picture at all, you should be still able to answer the question. So first off, what you do is you recognize, do I have an x-axis question or do I have a y-axis question? And again, that's given. So in this case, we have an x-axis question. So what I like to do is I like to draw a little rectangle. We'll call it like a little strip here. And I like to label it dx. Just to remind myself, just like with washers and with area, that everything has to be in terms of x's in my answer. So then what I do is I draw a shape. The shape that's given. So I'm just going to draw a generic square. And then what happens is, even if there's 4 sides of this square, I always think of the base of the shape as the most important side. So I'm going to be focusing on this side. Because how this works is, imagine if I cut this square out of the board, the base of this square would be glued to this strip of this dx strip. So again, you would take it out, you would twist it around, and then the square would be coming out of the board just like this, where this bolded base will be glued to this. But again, you don't need to know any of that if you don't want to think about the 3D picture. The process is the base of the shape, that was step 2, is always top minus bottom or right minus left. Because we're dealing with x's, it's going to be top minus bottom, so it's going to be 8 minus the function, so it's going to be 8 minus 2x squared. Again, this is the base of the shape, top minus bottom. Once you have the base of the shape, you should be ready to go for the answer. Notice that we have the base of the shape. We're able to go for the answer because we can use the base of the shape to find the area of the shape. What's going to be the area of the shape? Well, it's a square, so it's going to be base times height, where the base and the height are the same. So because we know the base, which is the most important side, then we'll know the height of this rectangle or the square. So it's 8 minus 2x squared. Again, the base tells us the height because the base is the most important side. Finally, what you do is you integrate the area of the shape. So what's the area of the shape? Again, it's this times this. So you can write it as 8 minus 2x squared. You can write it squared, or if you want to write it as base times height, you can write it like that. Then you write dx. Then you do have to choose numbers. So keep in mind that this point right here is 2, 8. Because we're dealing with x's, because at the very beginning they told me that it's perpendicular to the x-axis, the cross sections, I have to choose all x coordinates. So because this is 0, 0, and this is 2, 8, what's the leftmost x in this region? Well, it's going to be 0. What's the rightmost x? It's going to be 2. So it's going to go from 0 to 2. You don't need to put a pi in the front like the washer questions because you're not dealing with circles, you're dealing with squares. So again, this is the process. You don't have to think about the 3D picture at all. If you want, you can just go for the answer. So all this stuff is given. So right when you see x-axis, you think, oh, I draw this little strip. I need to do top minus bottom when I do my base. Then you draw the shape. In this case, it's a square. And the base of the shape is the most important thing, top minus bottom. So in this case, it's 8 minus the function 2x squared. So it's 8 minus 2x squared. Then if you have the base being top minus bottom, you should be able to find the area of the shape at that step. So what's the area of this shape? Well, in this case, it's going to be 8 minus 2x squared, because that's the area of a square, side squared. Finally, at the very end, you integrate the area of the shape. So this was the integral of the area of the shape. So 0 to 2 of the area. And why did we choose 0 to 2? Because we're dealing with x coordinates, because we're perpendicular to the x-axis. And that's how it works. Again, determine x or y, draw the shape, use top minus bottom if you're dealing with x's, or right minus left if you're dealing with y's, to find the area, the length of the base of the shape. Then use the length of the base of the shape to find the area of the shape, and finally integrate that, either going from x to x if you chose top minus bottom, or y to y if you do right minus left. So that's this. What we're going to do is we're not going to change the region in the next question. We're just going to change the givens, and you'll see that the givens are very dependent on how the question goes. So hopefully that makes sense. Again, draw your shape, top minus bottom for the base, find the area of the shape, integrate the area of the shape. So let's get going. Let's keep going. So for the next one, what I'm going to do is I'm going to change this to y-axis instead. And we're going to do the hardest shape, which is semicircle in my opinion. Or semicircle, I don't know how to pronounce this word. So basically what's happened is, because I'm dealing with the y-axis, even if I have the same region, so let's just keep with this region. Well, first off, what I'm going to do is a step that's ultimately going to be necessary is, again, because we're dealing with the y-axis, we have to change everything to be in terms of y's. So while this is y in terms of x's, I want to formula x in terms of y's because all my answers have to be y's. So I'm going to just solve really simply. It's going to be x is equal to, well, it looks like I divide by 2, and then I square root. So when I'm doing right minus left, because that's going to be forced because I have a y-axis, I'm not going to choose 2x squared. I'm going to write the equivalent of that function, but in terms of y's, I'm going to do the square root of y over 2. So that's that. So again, because we're dealing with y's, we're not going to have a dx strip. We're going to have a dy strip. So I'm going to erase this, and I'm going to write dy strip. So it's going to look like this. dy. And I like to label it dy because, again, it reminds me everything has to be in terms of y's. The numbers have to be in terms of y's, and also the function itself. So when I do right minus left, because it's right minus left, because the entire world is sort of twisted around, so instead of top minus bottom, it's right minus left. This is not the best picture anymore because I've kept erasing it and drawing over it. But when we do right minus left, when we do the numbers, everything has to be in terms of y's. So now we're ready for the question. So we did the easy step, identify its dx or dy. Now we deal with the shape. So a semicircle looks like this. So let's draw this. And again, as we deal with the semicircle, the most important part of this semicircle is the radius, because is the base of the shape. Sorry, it's the base of the shape, because the base of the shape is always glued to this strip. So what's happening is that this semicircle is coming out of the board like this. You don't have to picture it, but that's what's happening. So I need to find the base of the shape. Because we're dealing with y's, it's going to be right minus left. So what is the base of the shape here? Again, I'm not going to write 2x squared minus 0, even if this is the right function. The right function here, I'm going to do square root of y over 2, because I need everything to be in terms of y's. So it's square root of y over 2 minus 0, because that's the left side. I'm going to write minus 0 because I think it's pretty helpful to write minus 0, because I like to write right minus left. So again, because we're dealing with the y-axis, we're doing right minus left. So now the hard step. The hard step is use the base of the shape, which was top minus bottom or right minus left, to find the area of the shape. So how do you find the area of this semicircle? Well, what we need to do is we need to find the radius of this semicircle, because the formula for the area of a semicircle is pi r squared divided by 2, because the area of a regular circle is pi r squared. So for that semicircle, you divide it by 2. So keep in mind that while the base of the shape is the most important thing, because it's right minus left or top minus bottom, in this case, what is the base of the shape? Well, the base of the shape is actually diameter. So let's go for the answer. What's going to be this formula? What's going to be pi over 2, because again, this is the formula for the area of a semicircle, pi r squared over 2. Then in this part right here, I need to put the radius squared. Keeping in mind that this is not the radius, this is the diameter. So what I'm going to do is I'm going to write square root of y over 2 minus 0 divided by 2. This is the formula I want. One thing that's easy is choosing the numbers. Because I'm dealing with y's, I'm going to choose the y coordinate. So it's going to go 0 to 8 as opposed to the last question, which went from 0 to 2. So in this case, it's 0 to 8. Notice that when you're doing the semicircle, there's going to be 2 divide by 2's. And let me tell you why there's 2 divide by 2's. This divide by 2, which keep in mind is within the squared, is because we went from diameter, which was right minus left, the base of the shape, and we had to divide it by 2 to get radius. This divided by 2 is because we're dealing with a semicircle, so it's pi r squared divided by 2. So there are always 2 divided by 2's. This divided by 2 and this divided by 2. This one was because it's a semicircle. This one is because we were given the diameter, so we had to go for a radius. Even if this question is a little bit more complicated than our last question because we are dealing with a square in that example, it's still the same process. So let me recap this. So again, we have our nice, beautiful region. We have perpendicular to the y-axis, and we're dealing with semicircles. So what we're going to do is we're going to first note that everything has to be in terms of y's because we're perpendicular to the y-axis. So the first thing I did is I solved for x in terms or y in terms of x's. I brought over 2 and I square rooted because it makes the question a little bit easier. Then I'm dealing with semicircles, so I drew a nice little semicircle where the base of the semicircle is the most important side of that. That's right minus left. In this case, it's right minus left. So it's the square root of y over 2 minus the y-axis, which is represented by 0. So it's minus 0. So that's the diameter. Then I use the length of the base of the shape, which in this case is a semicircle, to find the area of the semicircle. So in this case, what I did is I divided by everything by 2. Then I squared it because it's r squared, so it's diameter divided by 2 squared. And then I have a pi over 2 in the front because it's pi r squared over 2 is the formula for the area of the semicircle. But it's still the same thing as that square example. Choose x's or y's. X is top minus bottom. Y's are right minus left, where everything has to be in terms of y's. Draw your shape. The base of the shape is glued to the thing. Use top minus bottom or right minus left to find the base of the shape. Then use the base of the shape to find the area. Integrate the area in terms of x's or y's, so be careful with the numbers, and you should be good to go. And that's how you do these cross-section questions. As you do them, you'll see that they can't really trick you. We'll talk about a few variations of this, but they can't really trick you too much. It's the same question over and over and over again as you get accustomed to it. There is one strange variation that I want to talk about with this region, so I'm going to erase this. but hopefully you have a general idea on the process. Again, x or y, base, area, integral. So let's erase this. So let's talk about this region for a little bit longer. Let's erase this because we're not going to do it in terms of y's. Let's do the x-axis. But sometimes they don't give you a shape, and it's actually a lot easier. Sometimes they'll just say the area of each of the cross sections is something like f of x, which is equal to x squared plus x. They'll just straight up tell you this function. So in this case, we're going to do the same thing though. Even if the shape is not given and they just tell me the area of each cross section, I still go for the same process. So first off, because we're dealing with the x-axis, I'm going to draw this kind of rectangle perpendicular to the x-axis. So this is the x rectangle. Then I go for my shape. Well, there's no shape to be given, so I can just draw an arbitrary shape. I don't know what it looks like. Let's just say it looks like this, whatever. And I can do base, but remember that the point of this, I'm going to erase this atrocity, but remember that you're always integrating the area of the shape. So in the previous two questions, we used the shape and the base of the shape to find the entire area of the shape. But if they just tell me straight up what the area of the shape is, I just have to integrate that. So what I'm going to do is I'm going to integrate x squared plus x. What numbers should I choose? Well, the numbers will be 0 to 2 because I'm choosing x coordinates. But notice that I can just integrate this. And usually they'll ask you to integrate this potentially with the u sub if the question is a little bit harder. But notice that I never use top minus bottom or right minus left at all in this question because I can skip all that step. They just were very, very nice and they just told me the area of the shape. So all I'm doing is integrating this. If you want, you can actually integrate this x cubed over 3 plus x squared over 2. You plug in 2 and 0. So this looks like it's going to be, by fundamental theorem of calculus, 8 over 3 minus 4 over 2. Because you plug in 2. If you plug in 0, when you do top minus bottom, you plug in 0. Zeros will go away because it's 0 to the third, 0 squared. So it looks like our final answer is going to be 8/3 minus 2, which is 8/3 minus 6/3. So our final answer is going to be 2/3. But again, this is such a weird variation of the question because there's not a regular shape. Just be wary that they ask this every like 7 years or so, where they're just nice to you and they find the area of the shape. What students get confused about is that they want to incorporate the region as much as possible, but every single time when you do these questions, you're always integrating the area of the shape. In regular questions, you have to use the shape and the base of the shape to find a formula for the area. But if they're nice to you and they just give you the area, you can just write that integral of the area. You should not multiply this, for example, by 2x squared because I already know the area of the shape. So I'm just going to find the area of the shape. And that's that. You just take the integral potentially and you just plug in top minus bottom, or you use the calculator, or you just set it up, no matter depending on what the question asks. But again, in these questions with cross-section, you find the area of the cross-section integrated. So in this case, they're being easy for you, but if they're not being easy, you use the base of the shape to find it. So let's do a different region and let's do 2 more questions and let's try to encounter normal questions, not like this one where they actually give you a shape. So I'm going to erase this. Let's deal with a different set of region. So in this case, I'm going to erase this beautiful picture and we're going to have a new region. So it's going to be this. We're going to have square root of x. We're going to somewhere across right here. And this line is going to be 6 minus x. And the region is going to be bounded by the x-axis this time. Then it's going to be the line y is equal to square root of x. Y is equal to 6 minus x. So it's this region right here. So what the first one we're going to do is we're going to do perpendicular to the y-axis. Then the shape is again going to be more normal. It's going to be a rectangle. So rectangle. And let's say that these rectangles have heights 3 times the base. So heights are 3 times the base. So this is going to be our 3 givens, and let's go for the question. So again, this region is a little bit harder because it looks like we have 2 different lines. Keep in mind that oftentimes the area and volume question, no matter if it's on A, B, or B, C, is on the calculator section. But one of the most important things is to find intersection points. So usually that's done with the calculator. You'll do the solve button or you'll graph. But in this case, this intersection point is going to be very important So let's note that this is going to be 4, 2. Again, usually you have a calculator and you'll probably already have found it when you do the area. I like to graph when I find these intersection points with the calculator when they're very, very complicated decimals, because I need both coordinates. Whereas if you use the solve button, you would only need the x coordinate. I like to find both coordinates at once, and that will allow me to put numbers on these integrals. But let's go for this question. So again, we're dealing with the y-axis. So because we're dealing with the y-axis, we're going to draw a dy rectangle. And before we draw this shape, we might as well change everything to be in terms of y's, because we'll know that that's a necessary step. So this is going to be pretty easy. Again, we wanted x is equal to something with y. Looks like we're going to have 6 minus y if you isolate. And in this one, it's even easier. Looks like we're going to just have x is equal to y squared. So when I do right minus left, which is going to be the case because I have the y-axis, x is top minus bottom, y is right minus left. I'm not going to choose 6 minus x and square root of x. I'm going to do 6 minus y and y squared. So let's go for the next step. The next step is to just draw a nice, beautiful picture of your shape. In this case, it's a nice, beautiful rectangle. And remember that no matter what, it's always the base of the rectangle that is the most important side. So what is the base here? It's going to be right minus left. Again, we're going to choose right minus left. Let me write this a little bit neater. So it's going to be the right function, which is 6 minus y, minus the left function, which is going to be y squared. So this was, again, right minus left because we're dealing with the y-axis that was given. So with the base of the shape, the next step is to find the area of the shape, but the area of the shape, of course, is base times height. What's the height? Well, they have to give us some sort of information about the height. Looks like it's 3 times the base, which is why the base is so important, because it tells you the height, and the base, again, is right minus left. So in this case, it's going to be 3 times 6 minus y squared. And once you have this information, you're ready for the integral. So I'm going to draw the integral. Remember that no matter what, even if they tell you the area, what you do is you're always integrating the area because the integral of area is volume. So it's going to be this times this. I don't have much space, so I'm going to just write it as 3 times this squared because they're the same thing. But you, of course, can write this times this. So it's going to be 6 minus y squared dy with a square with a 3. Then all that's left to do is just choose coordinates. Because we're dealing with y's and we like to label things with dy. I didn't do that in this case, but I like to label it at dy because it reminds me everything has to be in terms of y's. So I'm not going to choose 0 to 4 because I'm going to choose 0 to 2. What's the bottommost y I can choose? 0. What's the topmost y I can choose? 2. So it looks like this is going to be 0 to 2, and then you just type this in a calculator or you actually take the integral. Not the hardest process in the world. Again, same thing over and over and over again. Determine between dx or dy. If it's dy, it's a little bit more of a pain because you have to change the functions to be in terms of y's. So do that first. Find an intersection point if you need to, because you're going to use the coordinates of the intersection point later in the question. Then when you have everything ready to go, you draw your shape. In this case, it's a rectangle. Always it's given. Then remember that of the 4 sides of the shape, I believe that the base of the shape is the most important thing because this base is glued to this and the rectangle is coming out. The base of the shape is always right minus left or top minus bottom. So in this case, it's right minus left, which again, we chose the y functions of these functions. Then using the base of the shape, you should be able to find the area of the shape. In this case, base times height. They gave me that the height is 3 times the base. They have to give me this information so that I know the height. 3 times the base. And finally, you integrate the area of the shape, going to the right number. So in this case, it was y's, base times height, 3 times this square. And that's all it is. So let's do one more question, which is going to be a little bit different, as you'll see, but it's not that much harder. And let's just do that question. So let's erase this. Let's use the same region, and let's do the harder variation because we're going to be perpendicular to the x-axis this time. And then we're going to do isosceles right triangle. So I don't know if I can spell the word isosceles, but I believe it's this, isosceles. That's probably wrong, but I'm just going to assume that's right. Maybe a better thing is just to draw an isosceles right triangle. I'm sure that there's another S here, so I'm going to add an S right there. I might have made it worse, I'm not sure, but I'm going to assume that's how you spell isosceles. They will provide it for you if I misspelled it. So this is this region, but keep in mind that we're doing the same region. Because we're perpendicular to the x-axis, we don't have to care about these formulas in terms of y, so we're going to erase all of this, and we're going to go with the originals. So why is this one harder than most questions? Well, notice that because we're dealing with the x-axis, we're going to do top minus bottom. So it's going to be top minus bottom. But notice that top and bottom change. Over here, the top is the function y is equal to the square root of x. Over here, the top function is 6 minus x, so I have to do something. And just like with our volume by revolutions and rotations, or with area, if top and bottom changes, you just have to do two separate integrals. So basically, we're going to do two different questions where we're going to have one top minus bottom and we're going to have one top minus bottom. So let's do that. So instead of drawing one isosceles right triangle, what I need to do is draw two isosceles right triangles. So there's just one triangle right here. Hopefully you can tell that this is an isosceles right triangle where the bases are supposed to be the same, the legs of this triangle. And then we're going to have an isosceles right triangle right here. This is a little bit more isosceles-y, but again, one will be representing this guy right here, one will be representing this guy right here. The only thing that's hard about this question, it's a double question. So no matter what, it's always the base is important. The base is always top minus bottom or right minus left. In this case, because we're dealing with the x-axis, it's top minus bottom. So it's going to be square root of x minus the bottom. I'm going to write it square root of x minus 0. So that's the base of this rectangle, triangle, where this triangle's base right here is glued to this thing right here. So there's a triangle coming up. You don't need to know the 3D picture. Then for the second triangle, for the second half of the base, it's going to be top minus bottom again. But in this case, we're doing this separation because the top and bottom change. So it's going to be 6 minus x minus 0. So it's going to be 6 minus x minus 0. Again, this is top minus bottom, and we're doing 2 because top and bottom changed. Finally, because we have the base of the shape, we should be able to find the area of the shape, keeping in mind that isosceles right triangles are just half of squares. The base and the height divided by 2, base times height divided by 2, where the base and the height are the same because you have isosceles. I didn't even spell right triangle right, as I noticed there, so I'm going to squeeze in a t there. But none of that is important. It's base times height, so it's going to be square root of x minus 0 divided by 2. So now we're ready for the answer. Again, we're going to have two integrals because we had to split this guy up. So it's going to be the integral of base times height, but they're the same, so I'm just going to square it, divided by 2. You can take out the 1/2 if you want. Usually you would just type this in the calculator. Finally, what numbers are we going to choose? Well, look at this region right here. Because we're dealing with top minus bottom in the first half of the region, where do the x goes? Well, it looks like they go from 0, and the rightmost one is 4. So it's going to be 0 to 4. Then we're going to add a formula for this guy right here. So it's going to be the integral. It's still base times height divided by 2. So it's base times height, 6 minus x minus 0. But because we're dealing with an isosceles right triangle, the base and the height are the same. So I'm just going to square this. Then I'm going to divide by 2 because we're dealing with a right triangle. Base times height divided by 2. Finally, last little step here. What are the interval? Well, again, you choose x point, so it looks like it's going to go from 4 to whatever x point this is. This is 6 comma 0 because it's the x-intercept of this function right here. So it's going to be 4 to 6. So again, even in the hardest variation of this question, which was an isosceles right triangle, x-axis where you have to split it up, it's still the same process as normal. Given a perpendicular to the x-axis or the y-axis determines whether you're going to do top minus bottom if it's the x-axis or right minus left if it's the y-axis throughout the question, and it determines if you're going to choose x numbers or y numbers, again based off x-axis or y-axis respectively. Then you're going to have a given shape, and what you do is you draw that shape and you really focus on the base of that shape, because the base of the shape is going to be top minus bottom if you're dealing with an x-axis question, or right minus left if you're dealing with a y-axis question. So you just do top minus bottom or right minus left. Keeping in mind if you do right minus left, you do have to change the functions to be in terms of y's. Once you have the base of the shape, then you find the area of the shape by using some geometry formula, 1/2 pi r squared for those semicircles, base times height for squares, base times height for rectangles where you probably know something about the height, or base times height divided by 2 for isosceles right triangles where the base and the height is the same. When you have the area of the shape, or if the area of the shape was given to us initially in the question, you're always integrating that thing. So in this case, it's the integral of the area of the shape, the integral of the area of the shape. Keeping in mind that if top and bottom, or right minus left, do change, you do have to do 2 separate integrals, one for each one. But that's all it is. Again, usually people can dominate these free response questions as they practice more and more because the variations themselves are not actually that hard. It's not as hard as, for example, integration methods, in my opinion, when you're doing U subs or when you're doing partial fractions, because usually you just type these integrals into calculators or you just set them up. It's the same thing every single time. X-axis or Y-axis, where Y-axis you have to change everything in terms of Y's, then draw your shape. Base of the shape is top minus bottom or right minus left. Then you find the area of the shape using the base of the shape. And finally, you integrate the area of the shape, being careful with your numbers, X's or Y's. And that's the process of volume by cross-section. If you want more practice with this, which I highly encourage you to do, because again, as you do more practice, you'll be able to master this concept. Check out our Girls Teach Calculus video, which I'll link in the description below, where one of my former students practices a lot of various questions. She'll practice variations of this. So she'll do questions like this one that are perpendicular to various shapes. So the cross sections could be squares, semicircles, isosceles right triangles, and rectangles. Then she does ones where she has to do x-axis or y-axis. She has some where she has to split it up, just like in this one. She has some where the area is just straight up given. So watch that video if you want more practice. She probably explains things a little bit more slowly, a little bit more clearly, a little bit less redundantly than I do. But hopefully this was useful for you. This is, again, a topic that you can master with a lot of practice. I think this is easier than volume by revolution. Go back and check out our video on that if you need to. Our next video, if you're in BC, will be on ArcLink. But if you're not in BC, if you're in AB, this concludes our area and volume playlist. Hopefully this has been useful for you. If it has, of course, give us a like and subscribe. We really appreciate it. But no matter what, I hope to see you next time. Thanks again for watching, Just Like Normal.